So to summarize, right, what is the difference between a mutex and a spin lock? What is the kind of context in which it can be used? It should be used only in a process context because it may sleep, right? Whereas a spin lock can be used either in IRQ or process context, but it never sleeps. In an IRQ it makes perfect sense. In a process context you have to be careful. Remember, the main thing is a spin lock should not take too long, okay? Behavior wise, the scheduler may switch. It generally sort of ensures fairness and there is very little wastage of CPU time. But a spin lock is a busy wait, right? That while loop is just continuously checking a particular value and spinning over there. It is very tiny and it should be used only for fast sections. It is going to waste CPU, clock cycles, right, and power consumption if you are worried about that. The use cases, as I said, as you can imagine, right, mutexes are used in processes where you have long operations, things like copy to user space, parsing input, which to us sounds very easy, but for a computer is actually a fairly complicated thing because it sort of needs to check character by character whether this is a string or an integer or what kind of thing it is. Extracting something as simple as a number from a string of bytes is a non-trivial thing to do, right? Allocating memory can be another thing which is a long duration operation. So all of these, if at all you need to make sure that there is no concurrency issue over there, protect them with a mutex. Spin locks are used for things that are shared with the IRQ, things like the IRQ count, wait count and so on, right? Very short updates only should be protected with spin locks. And in general, if you are using a spin lock inside an IRQ, right, use spin lock IRQ-Safe. The reason for doing that is to make sure that you do not get another IRQ while you are in the middle of handling that critical section that has been locked. Okay. So in general, some do's and don'ts as far as locking, right? Use spin lock IRQ-Safe, especially if you have data that is shared with the IRQ. What does that mean? You are using it in the IRQ, but you are also using it in the process, right? So for example, in the case of the smart timer, the wrap count was being updated inside the IRQ handler, but was also being read in another place where you had the thing which required you to actually print something out onto the screen, right? Keep the critical sections as short as possible, and the kernel also provides two macros that are useful, the write ones and read ones, okay? And these macros essentially tell the kernel that you are trying to write to a particular memory location or read from a particular memory location. It ensures that there is no problem with caching, that it can never get optimized away by the compiler, right, and that it is actually going to guarantee that the read or write actually happens. Okay, so these macros are there to sort of prevent any compiler optimizations from just getting rid of that particular piece of reading or writing that you wanted to do, right. In general, as far as what you should not do, right, taking a mutex in an IRQ, as I explained already, you do not want to go to sleep inside an IRQ handler. You should not sleep in an IRQ or a tasklet. The tasklet is essentially the part that needs to be finished very fast. And do not hold a spin lock across something like copy to user, which is a long duration operation. It is not just about copy to user, anything which is a long duration operation, you should not take a spin lock across it. Okay. So these are, as I said, sort of rules of thumb of how to go about implementing the IRQ handlers, right. In general, there are more or less standardized templates that are there for most cases, and in most of the time what we are going to be doing is only making minor changes to those rather than writing fresh interrupt handlers completely from scratch. So far I talked about the top half, the interrupt handler, the IRQ handler itself, right. But clearly there would be a scenario where I want to do more complicated work, maybe copying data from one place to another, allocating memory, right, reading or writing files and so on. What we do is we declare some kind of a work function, right, something which is a more complicated function but can sleep, right. And this is important. It means that I need to sort of accommodate the fact that there is a possibility that that entire function can go to sleep somewhere. It will be woken up eventually by the OS, but I cannot guarantee how long it will take to run. Okay. And what that means is, in my IRQ handler, I basically acknowledge the IRQ, do some bookkeeping meaning that keeping track of the IRQ counts, incrementing any atomic variables that I have and so on, and then schedule the work, right. Scheduling the work essentially is sort of deferring the work and saying, okay, now go do this some other time later, right. Tell the operating system that it has to be something that gets done later. This part of it, the tasklet, is basically the IRQ handler. It is atomic, it is very short, but this part out here, the work function, can be in process context, it can take longer, it can even sleep, right. Why are we going on about this sleep? The moment the possibility of sleeping in a function occurs, it means that we cannot guarantee how long the function will take to execute, right. So, which is why I keep using that word it can sleep as a way of sort of saying we do not know how long this particular function will take to execute, right. So, the work function is going into a queue, that is what the schedule work does, right. It basically says I am going to take this particular function and put it onto a queue which will be woken up by the operating system as and when the OS finds free time and can then go ahead and run. Okay. So, just to summarize, a tasklet runs in the IRQ context, it is atomic, very short work, no sleeping allowed, right. The work queue on the other hand is in process context, it can sleep, it can do IO, it can allocate memory, it can do things that are long running, right. And in general, right, so as we can see over here, this tasklet or the IRQ handler is the top half, the work queue is the bottom half. And a general guideline is that it is usually a good idea to prefer a work queue, assign a task for later completion, unless we need an atomic bottom half. Okay. Now, there is a possibility that I can finish everything within the tasklet itself, all the work is completed there and I do not need a separate bottom half as such. But if at all I need a bottom half, the expectation is that it is something that can potentially take longer, right, in which case try and avoid things that need an atomic completion, right. So, if I can sort of defer something into a queue and let it run later, that is preferable.